you need to get into the conceptual learning in physics, then only the entire mechanism, the entire things, the concept will create a visual effect in front of you. It will create a visual effect in front of you when you will learn the concepts with the thorough continuous process of learning. Then only you will be developing the understanding of the subjects, and you will be thorough in your subject. Everybody use this concept. Yes, physics should be learned conceptually, but they do not learn so spontaneously going through each and every argument. They just start run after the what is the formula to fit in what particular situation. Just running after the mathematical formula based on one situation to another and then to another, you will never be able to reach to that conclusive argument what can help you to learn concept. Now suppose likewise two velocities I explained having Vx and Vy. Likewise this two velocities Vx and Vy. Again I am giving two velocity. Vx is for example 4 meter per second, but Vy is I am mentioning it something for example 1 plus t meter per second. Try to understand it now. It's an interesting discussion. I am going to do it now. This time also again I am taking two velocity mutually perpendicular to each other, one along the x direction, another one along the y direction, right? But the difference is this time Vx is constant, but Vy is variable. Why it is variable? Because you can see the expression of Vy, it is depending on the time t. It is depending on the time t. So suppose if a particle is allowed to move for a time of 4 seconds. For example, a particle is allowed to move for a duration of 4 seconds. So what will happen during the 4-second journey? The x direction velocity will remain constant, right? X direction velocity will remain constant. But if the y direction velocity, which is generalized, which is given with the general term 1 plus t, so do you think that in y direction velocity value will remain constant during the 4-second journey? Do you think that the y direction motion will be continued with the same velocity? Of course not. Y direction velocity will be continuously changing. So can I say, based on this, can I say that the particle is having at one instant, particle is having x direction velocity 4 meter per second, and along y direction it is having velocity as well as some acceleration? Am I correct or not? If I am saying that in y direction particle is having the velocity which is variable in magnitude, with time it will keep on changing, right? Does this mean who can make the velocity changes? Who takes the responsibility of bringing change in magnitude of velocity? Who takes the responsibility on behalf of changing magnitude of velocity in a particular direction? It is nothing but other than acceleration, because we know that acceleration is change in velocity by time taken. We know that acceleration is change in velocity by time taken. So in any direction, if we can see during motion, if a body is found to be changing its velocity magnitude in any particular direction, that means it is having acceleration available on it in that direction. So ultimately I am coming to the conclusion that acceleration is available along with the velocity in a different direction than that of the velocity, which the general explanation I gave, the reasoning for curve motion, yes or no? Tell me, are we coming back to that conclusion or not? That's why I said that when a particle will be having multiple velocities, it can still follow the straight line, but the condition is all individual velocity components need to be constant in magnitude. Whenever any one of them will vary, that means it will automatically introduce that variation in its value will automatically introduce or will automatically answer about the presence of acceleration in that direction. So what will happen? I can draw a few consecutive component velocity diagram. Suppose that the starting instant I can see x velocity is this much, y velocity is initially at t equal to 0, y is only 1. So this is the y component and x component value. At the next instant, x component is still same in magnitude, so I can represent the x velocity by drawing almost the same length along x. But you can see now I am showing y component velocity by drawing a line little bit more than the line that I have drawn here, because y velocity is increasing in value, right? In next instant again, if I show the same length of x velocity, because x velocity remains constant, but to represent y velocity I am further drawing it with the bigger line. So are you understanding me or not? Are you understanding what kind of changes I am talking about? So particle is able to travel more distance along y because of increasing y velocity value, and who is helping it? The presence of acceleration along y direction. So ultimately what will happen? The particle will claim to cover more y distance in during the next few seconds. Are you all understanding me? So therefore, as I said that at every instant the net velocity will be decided by the resultant one. So let's decide the net velocity at the starting instant. This is this one. So geometrically now let this angle is theta 1. So after some time it is observed that this time the x, we can see here, this is the how the particle is enforced. This is how the particle is enforced to keep changing in its direction of motion when one of the component velocity keep on changing. Now these are the three distinct consecutive instants picture. If you assemble them, so overall character you will be able to see particle initially was trying to move along this, next instant it is trying to move along this, next instant it is trying to move along this. So are you observing the continuous change in direction? Yes. Are you able to understand the change in direction? Because see that at the for starting instant it was like this, next instant it is like this, next instant it is like this. So it is continuously changing. I am just showing few consecutive stopwatch moment effect. I am just showing few consecutive stopwatch moment effect. Ultimately it will happen what? Will it travel along one straight line for few seconds? No. This change will continuously happen at each and every stopwatch moment. So the collective effort will take the path like this. Are you getting it? The collective effort will take the path like this. So are you getting a curve motion now? Are you getting a curve motion now? So tell me, what is it interesting? Is it interesting or not to know the complete mechanism or analysis? This is the way you need to get into the conceptual learning in physics. Then only the entire mechanism, the entire things, the concept will create a visual effect in front of you. It will create a visual effect in front of you, and nobody will need to push you something by thrust to understand this kind of things. And when you learn the concepts with the thorough continuous process of learning, then only you will be developing the understanding of the subjects, and you will be thorough in your subject. Everybody use this concept. Yes, physics should be learned conceptually, but they do not learn so spontaneously going through each and every argument. They just start run after the what is the formula to fit in what particular situation. Just running after the mathematical formula based on one situation to another and then to another, you will never be able to reach to that conclusive argument what can help you to learn concept.